Last time, we started discussing the different decision tools that managers may use to decide which projects to accept and which ones to reject. We looked at what NPV is, how to calculate it, and how to use it to decide whether to accept or reject a project. This time, we will look at a second decision tool, namely the internal rate of return, IRR in short. We will look at how to calculate it and how to use its value to determine whether to accept or reject a project. We will also define the third investment decision tool, the payback period. We will see how to calculate it and how to use it to decide whether to accept or reject a project. The internal rate of return tells us what annualized percentage rate of return a project generates on the initial investment made at time zero. It is calculated as the discount rate that makes the NPV of a project equal to zero. Let's revisit our project from last time. The project required an initial investment of $1 million at time zero, which resulted in annual end-of-year cash flows of $200,000 for the next 9 years. At a discount rate of 15%, we calculated its NPV to be a negative $45,683.22. Now we want to find its IRR, which is the discount rate that makes NPV zero. So we have to solve the following equation. Minus $1 million plus 200,000 divided by 1 plus IRR raised to the power of 1 plus 200,000 divided by 1 plus IRR raised to the power of 2 plus so on until 200,000 divided by 1 plus IRR raised to the power of 9 equals 0. However, solving this with a calculator will be difficult as it is a nonlinear equation in IRR that cannot be simply rearranged and solved for IRR. Luckily for us, Excel has an inbuilt IRR function that precisely solves this equation. Input the cash flows in chronological order, starting with the initial cash flow of negative $1 million at time zero and then 9 annual cash flows of $200,000 each. This should be spread across 10 cells on the Excel spreadsheet, as you can see. In an empty cell, you may type equals IRR, open parenthesis, and then select all the 10 numbers that you just entered into the Excel spreadsheet. Finally, close parenthesis and hit return. You should see the IRR value to be 14% in this cell. You can increase the number of decimal places to 2 and you will see that the IRR is 13.70%. The annualized rate of return from this project is 13.70%. But how do we decide if this return is acceptable or not? Earlier in the course, we talked about the discount rate being the cost of raising capital for a company. It is how much return investors expect as compensation for holding the risk of the company or project. We also refer to the discount rate as the hurdle rate. The hurdle rate is the minimum return investors should expect to earn from investing in a project or company. Any return greater than the hurdle rate tells us that the project or company earns more than what investors want as compensation for risk. Our decision rule for IRR is if the IRR is greater than the hurdle or discount rate, we should accept the project. Otherwise, we should reject the project. In most cases, both NPV and IRR will give us the same decision. If IRR is greater than the hurdle rate, then NPV will be positive, while if IRR is less than the hurdle rate, then NPV will be negative. We will look at some exceptions to this rule later in the course when we talk about the drawbacks of these methods. Going back to our example, the project's IRR is 13.7%. When we calculated its NPV last time, we used a discount rate of 15%, which is its hurdle rate. Given the risk of the project, investors expect a return of at least 15%. However, the project returns only 13.7% and hence we reject the project. This is the same decision we arrived at using NPV last time. This is consistent with what I said earlier about IRR and NPV giving you the same decision in most cases. Moving on, let's look at the payback period. This is the third common investment decision tool managers use. It tells us how soon we recover the initial investment we make in a project. Let's revisit our example. The project required an initial investment of $1 million at time zero, which resulted in annual end-of-year cash flows of $200,000 for the next 9 years. How soon do we recover the initial investment of $1 million? We recover $200,000 by the end of the first year. That means we still have to recover $800,000. Once we recover $200,000 in the second year, we still have to recover $600,000. This accumulation of cash flows continues until we recover all $1 million. By the end of the fourth year, we have recovered $800,000 and have yet to recover $200,000. We recover exactly that amount at the end of the fifth year. It takes 5 full years to recover the entire initial investment of $1 million, which means that the project's payback period is 5 years. What is the decision here though? Should we accept or reject the project? That depends on whether we think 5 years is an acceptable time to recover our initial investment of $1 million. Unlike NPV and IRR, there is no economic rationale for deciding whether a given payback period is acceptable or not. We may have a general rule that says that any project with a payback period of 3 years or less is acceptable. In that case, this project should be rejected as it takes longer than 3 years to recover the initial investment of $1 million. This is one of the drawbacks of using payback period as an investment decision tool, but we will discuss this and other drawbacks of these methods later. Next time, we will look at an example on how to use these decision tools when comparing two projects.